Okay, Algebra 2. This should be a fairly short video to start off your Monday. This is the last week that I will be posting stuff for you to do. So Friday will be the last day. This Wednesday, we will, or I'll give you your chapter review or your semester review, I guess, packet. I will post that, and so we'll start semester review. So 2 more days of kind of this type of review, and then I'll give you that packet, and then we will be done on Friday. So this should be fairly short. You should have a sheet that looks like this, radical equations. And the first thing I want to start off by is basically what we're trying to do is we're solving for x here. We've talked before about how, like, if you have an x squared, so let's say x squared equals 4, to get rid of the square, you would take the square root, okay? And when we insert the square root in there, we need to make sure we have plus and minus. So x would end up being positive and negative 2 in this case if we are solving this problem. Now, if we're working backwards, though, the inverse of the square root is squaring it, okay? And when we square something, it kind of gets rid of the plus and minus sign, because when you square a 4 versus squaring a negative 4, that will end up going away. So in this case, our answer will just be x equals 16. And so that would be the same for if they would have given me the square root of x equals negative 4. What I would do is I would square both sides, and squaring a negative 4 is negative 4 times negative 4, which is still positive 16. So for this reason, this is why we need to have plus and minus when we take the square root. Here we're squaring, so we're doing the opposite of that. Okay, and those two things are inverse operations. Square rooting and square are inverses of each other, and that's why they kind of undo each other. Okay, so we'll do a couple of these. I have them kind of circled going through here, and then we should be done. This should be fairly short. So I'm solving for this x plus 2, and the important thing is that you cannot move anything if it is underneath of the radical symbol. So like I can't subtract that 2 over to the other side because he's trapped underneath of there, okay? So what I want to do first is I want to get rid of that square root by squaring both sides. But since there's a square root on this side as well, the square root of 3 squared is just going to pop out as 3. It kind of, does the same thing to both sides. This is going to be x plus 2 just popped out, okay? And then I just solve like normal. I'm going to subtract that 2 now that he's outside, and I'll just have x equals 1. So that's kind of what he will look like. Ooh, fuzzy. And then notice, I guess, if you plug the 1 back in, so if I plug 1 back in for x, this would be the square root of 1 plus 2 equals the square root of 3, which is true. Those two things both check out. So I know that x equals 1 is my correct solution. Okay, for number 2, I don't have a square root on the other side, but I'm still just going to square both sides. So the square root of that guy squared is going to pop out the 2x plus 15, because that just kind of makes those two things cancel each other out. On the right side, I have 6 squared, which is 36. So notice over here, I didn't square the 3 to make it become 9, because I had to get rid of the square root. Okay, this one doesn't have a square root, so I actually do have to square that 6. Okay, then what I'm going to do is I'm going to subtract 15 from both sides. Okay, 2x equals whatever that is, 21 maybe? 21 divided by 2. So this is 21 divided by 2, or 10 and 1/2, 10.5 is what he will look like. Okay, and then again, I can plug that back in and solve. 2 times 10.5 is 21. 21 plus 15, if I add those two together, that's 36, and the square root of 36 is 6. So I've checked my answer. We're good to go. Okay. All right, I'm going to have you go down to number 5. Okay, number 5 is kind of the same way. We'll do another one of these. So this one, you would square both sides. Again, just like number 2. The 5x. Oh no, wait. You can't see it. Shoot. Do you see this little 3 right here? I've kind of circled over top of it. Sorry. That's why I circled this question. Huh. It's not exactly the same as number 2. This is a cubic root. That's important. Okay, so to get rid of a cubic root, what I have to do is I have to cube it. Okay, so rather than taking this, squaring it, because it's a square root, this time I'm going to cube it. Okay, so what's going to happen is it's still going to cross that stuff out on the left side, so I'll still be left with 5 minus 11x. But on the right side, instead of this being 3 squared, it'll be 3 cubed. 3 times 3 times 3, 3 times, which is 27. Okay, so that's the only difference. If you have a 3 there, that little inserted 3, that's cubic root. So to undo that, you would have to take him and cube him. Okay, so now I'm going to subtract the 5. So I have negative 11x equals 27 minus 5 is 22. And then I can divide the negative 11 over to the other side. X is going to be equal to negative 2. Okay, I want to plug that back in. The cubic root of 5 minus 11 times negative 2. Okay, negative 11 times negative 2 is 22. 22 plus 5 is 27. And the cubic root of 27 means, what do I take times itself? 3 times to get 27, and that is 3, just like it says over here. Okay, so I've kind of undone that, and then I can check my solution. Okay, so let's go to this one. Let's go to number 9. Okay, now when I have a whole bunch of extra junk in there, like this 7 is kind of extra, it's on the outside. I want to first isolate the radical, which means get the radical symbol by itself. So everything that's trapped underneath of there is still trapped, but stuff that's on the outside I can move to the other side. So I have to get that to the other side in order, before I can even cube this thing. So I'm going to subtract the 7, and I have the cubic root of 2x minus 1 equals 10 minus 7 is going to be 3. And then to get rid of that cubic root, I'm going to cube both sides. So that cancels him out, cube that side. So I have 2x minus 1 equals 3 cubed. We just did that, was 27. Okay, and then I just keep going like normal. Now I can move this stuff to the other side. So I'm going to add the 1. 2x is going to be equal to 28. Divide by 2. X is 14, I think. Okay, let's plug back in and let's check our answer. So I have 7 plus the cubic root of 2 times 14 minus 1. And I want to check to see if that's equal to 10. So 2 times 14 is 28, minus 1 is 27. The cubic root of 27 is 3, and 7 plus 3 is 10. Check. Good. We did it right. Okay, last one, number 10. I want to solve for this x inside of here, but I have to get rid of everything else around it. So here we have 2 things that we have to move. We have to move the negative 9, we have to move the 3. So think about which one you're going to move first. Negative 9, you're going to move the 3. We are going to add 9 to the other side. Okay, so 3 square root of x equals 3 plus 9 is going to give me 12. And then what I can do is, to get rid of that 3, I'm going to divide by 3. So the square root of x is going to be 4. And then I'm going to square both sides, okay, to get rid of that square root. And x is going to be equal to 16. Kind of like our first example was. That's kind of nice. Okay, let's check. 3 square roots of 16 minus 9, is that minus 9? Equals 3. Yep. Now the square root of 16 is already there. We don't have to have plus and minus. So the square root of 16 is 4. So I have 3 times 4 is 12 minus 9 equals 3. Yep, that's right. Okay. All right, so kind of a short video there, but just kind of going through those radical equations. In the next video, we'll do some polynomials, and then we will be on to our final review. So there you go.